Okay, so we're gonna find the derivative of y with respect to x using implicit differentiation for this equation. So let's just go ahead and let's get started. So on the left here, we're gonna use the product rule because we have one function times another function. So we take the derivative of x, which will just be 1, times, sine of y, just leaving it as is. And to that, we're going to add x and then multiply by the derivative of sine of y. So remember, that's our second function, which will be the cosine of y. Now, in implicit differentiation, when you're trying to find dy over dx, you're going to need to multiply this by dy over dx whenever you're differentiating a function of y. So this will be times dy over dx. That's really the main additional step you have to remember. It's a little, it's a little weird to get used to at first, but once you do a lot of these, it gets pretty simple. Okay, so this will be equal to, and again, we have the product rule on the right side again. We have the function here and another function here. So we're going to take the derivative of y first, which will be 1. And then again, we're going to multiply that by dy over dx because we have a function of y. And then we're going to keep that, keep the cosine of x as that. So this times cosine of x. And then we're going to add y. And then we're going to multiply by the derivative of the cosine of x, which will be the negative sine of x. Now our goal is to solve for dy over dx, and you want to treat this like a variable. Think about solving for this thing by dividing, multiplying, subtracting terms, that sort of thing. So let's bring all the dy dx terms to the left and everything else to the right. So what I'm going to do is I'm going to add this. I'm going to add sine of y to both sides, and let me move this to the front. So I'm going to add sine of y. And then, let me take 2 steps actually, that I don't want to confuse. So let's have cosine of y times dy over dx is equal to this whole thing, dy over dx times the cosine of x minus y times the sine of x minus the sine of y, because that's what I subtracted from the left. And then I'm going to subtract this term right here. I'm going to subtract dy over dx times the cosine of x from both sides. So then I'm going to have the cosine of y times dy over dx minus dy over dx times the cosine of x. That'll be equal to the negative y times the sine of x minus the sine of y. And then see here, I have a dy over dx here and a dy over dx here. So I'm going to factor this out. I'm going to factor it as if it's just a variable. So treat it like a variable. So what I'm going to move the dy over dx in front, and dy over dx will be multiplied by this term, so times cosine of y, and minus the cosine of x. And all of that will be equal to negative y times the sine of x minus the sine of y. And then I simply divide by this. So I divide both sides by the cosine of y minus the cosine of x. So that'll cancel, and I'll just get that dy over dx will be equal to this over the cosine of y minus the cosine of x. I can't really do much with that, so that'll be my answer. And let's do one more. Let's do here we got cosine of x plus y is equal to x. So we're going to use implicit differentiation again. And what we have is the chain rule. We have a function within a function. So we have, let me rewrite this. Let's put this in purple. So you have the cosine function on the outside and have the x plus y function on the inside. So first I'm going to take the derivative of the outside function, which will be the derivative of the cosine function. So that'll be the negative sign, and leave the inside the same, the negative sign of x plus y. And then from that, I'm going to multiply by the derivative of the inside. So the derivative of the inside, we're going to have the sum rule. So the derivative of x will just be 1 plus the derivative of y, which will be 1. But since I'm differentiating a function of y, I'm going to multiply that by dy over dx, since we're doing implicit differentiation. And this will be equal to the derivative of x, which will just be 1. And then so now it's again just an algebra game. I need to solve for dy over dx. So I'm going to divide by this negative sign of x plus y. So then dividing both sides by this whole thing, I'll get 1 plus 1 dy dx, or 1 plus dy over dx is equal to 1 over, 1 over this, 1 over the negative sign of x plus y. It's kind of funky. And then I'm going to subtract 1 from both sides to get the dy over dx by itself. And then I'll get dy over dx will be equal to 1 over the negative sign of x plus y minus 1. And this is your final answer technically, but maybe you want to simplify. Your textbook probably won't have it like this. So what I'll do is I'm going to make a common denominator here. So then making this as, the negative sign of x plus y over the negative sign of x plus y. Because remember that 1 is always equal to the same expression over the same expression. So I'm going to have 1 minus the negative sign of x plus y on top. So dy over dx will equal to 1 minus the negative sign of x plus y, which is 1 plus the sign of x plus y, all over the negative sign of x plus y. And that'll pretty much be my answer.